Previously, last week, we talked about how networks can be set up and how devices can communicate with each other. One thing that we need to think about is, in order to communicate, we need to have some protocol, we need to have some etiquette, we need to have some set of rules. So protocol is nothing but a set of rules and conventions that determines how we exchange information. So the network is where we're going to talk about. And the standard is what definition do we agree upon for a protocol, right? So those are protocols, and so that's something that we're going to focus on is what are the standard protocols and standards that are available for networking. So if you use proprietary protocols, you can only communicate with equipment manufactured by that particular manufacturer. But if you have a standard protocol, you can universally communicate. Think about different devices, USB drives, things that we use that you're able to, like a thumb drive, that you're able to plug in into different devices, into different operating systems. And the reason why it works is because they use a particular protocol standard. Now, there are a lot of industry standards out there. So something that you can do this week is kind of go through these different standards. If I were to teach this in the classroom during lecture, I would have made you go to these different organizations and research around and kind of see what they do, right? Some of these you might have seen posted as stickers on equipment, devices. So what are these different standards, right? So if you notice, for different things there are different standards. So if you're using Wi-Fi, wireless fidelity, that's what it stands for, they have to, you have to have products tested for 802.11, standard for wireless operability and capability. What does that mean? What is that 802.11? We'll actually see some of those numbers. Those are actually a request for proposal, coming up with this standard, and everyone agrees to the standard, and then it becomes kind of like a bill becomes a law, right? So kind of like similarly, but it's really different organizations interested in being able to interoperate, right? So that's when you come up with a standard. Wireless Local Area Networking Association, in charge of training for Wi-Fi, IETF, which we'll talk about, it's mostly for internet. FCC, you probably heard this word many times, Federal Communication Commission, that's in charge of regulating standards for communication, which is TV, cable, wireless, radio, satellites, all these standards. So you have to comply with their standards and rules or that they come up with. ANSI, American National Standards Institute. It's for the safety and health of consumers and the environment. ISO, which is for iOS, which is actually coming up with the networking standard, which we'll talk about today. IEEE is in charge of, it's the Institute for Electrical and Electronics Engineers, which actually comes up with a lot of electrical standards, electronic standards that you see. There's also ETSI, which is for European Telecommunication Standards. There's International Telecommunication Unit, that's for communication across the globe. And also there's a UL, which is Underwriters Laboratories, which are for standards and test procedures for products. So a little bit about, that's a high-level overview, a little bit more in detail about each organization. Something that, you know, we are going to do web pages and things, so something that's really important for us when we're thinking about web is IETF. It's an international community of engineers, designers, operators concerned with how the internet is evolving, architecture is evolving. And it's open, this organization is open to any interested individuals. So usually the technical work is done in groups, working groups, like a focus group, and they divided by topic, routing, transportation, security, etc., related to the internet, obviously. and they come up with different standards within these working groups. Something that you might be we will be talking about is assigning unique names and IP addresses. How when you have a web domain, how do you come up with a unique domain name, and how do you own that domain name, and how to assign an IP address? Whether you if you're in the United States, what your extension for your domain name, if you're in Canada or UK, how you have CA, UK, these kinds of things. So some of those things are important. The standards are important. So that's what this. So the way it works is, you come up with a proposal and you request for comments, and then you discuss and you agree upon these standards, and that's how internet standards are made. One of the oldest organization, Institute of Electrical and Electronics Engineers. I used to be a member a long time ago when I was doing my engineering. Some of the 80s, so the numbers that you saw previously, 80211, if you notice, came from this committee. So they develop the networking standards, how the cable needs to be, what protocol it needs to follow so that you have Wi-Fi capability and things like that. So these work groups define the standards. So some of those, the 802.11 wireless standard is something that's derived from these standards that you see. So there's standards for different things. If you're using fiber optics, you're using broadband, what are the different things? So we can, the point is again to be able to intercommunicate between different devices and different things here. So there are working groups for different things. This slide might be slightly outdated because I haven't gone out there and looked for the latest things within here. But these are the different working groups, and they come up with the standards. So the size of the cable, the bandwidth of the cable, and how far it needs to be transmitted. All these rules are come up within these subcommittees. So we will be talking about hardware and some of these things, so you'll see these slides again. But so here it's talking about a cable specification. So some of these cables you've seen, like this cable is you're really familiar with because that's an internet cable. Although these days we use Wi-Fi, but if you're physically wired into the network, so this is a network cable, also called a Cat5 cable, category 5. And so there are different things. So they actually have some specifications. So here it says base or, so it could be base or broadband. Base means the signal can only go in one direction. And broadband means you can actually send multiple signals within there. So that's where the term broadband comes in cable. So the 10 is the speed, the networking speed in megabits per second, right? So the more, the better it is. The T is the type of the cable, and so if it's 2, you have the 10-base-2 cable is good up to 200 meters where the signal doesn't deteriorate. So if it's 500 meters, right? So the L is used for fiber optics. So some of these are for the types of cabling that you're using as well. So other standard groups out there, Wi-Fi, UL, FCC, all these other standards that you see that we will actually run into as we talk about different standards. So this is probably the most common one, so that you have, we only are interested in whether we have Wi-Fi or not, right? So, but this is what makes it possible for us to have that within there. One of the most important things for us is ISO. So ISO is an international organization for standardization. So this organization is in charge of telling us what are the different layers of networking. How can we communicate between different devices? So it's supposed to be, if you notice, it should be iOS, but it's actually ISO, which is actually derived from Greek isos, so which means equal. So ISO.org is where some of these networking standards or some of these are published that we're going to talk about shortly. It's a non-governmental organization, so kind of like non-profit. It's a term that NGO is a term that they use internationally. We tend to use non-profit for the same intention. So something that we're interested in is understanding how networking works, right? You know, how are these protocols maintained? So think about how when you're thinking about an airline, you know, to understand networking better, let's look at an analogy of an airline system. So you have ticketing agents, you have baggage checkers, you have gate personnel, you have pilots, you have airplanes. So you have all these different components that come together to get us to fly from place A to place B. So the same thing that you can also think about in networking. You actually send an email from one computer and it went all the way to the destination computer. What we're looking for is structure. So what we can think about is how they can be divided into layers, right? Each layer combined with the layers below provides a functionality or service. So for example, you can think that from ticketing layer and above, right, and airline counter to airline counter, transfer of person, so things like that. So you can kind of think about layers of functionality here. So each layer provides some function or performs some function within that layer, and it uses the service of the layer below, right? So the advantage to using this kind of layered architecture is modularity. So you can change the implementation, you can change how things work within that particular unit and not affect the rest of them. So you're able to still do the work without having to worry about the tiny details within there. So to provide network structure to design of network protocols, each protocol belongs to one layer, just like airline function belong to one layer. So each layer provides service by performing certain actions within that layer and using services of the layer directly below it. So ISO came up with the networking standards for how we're able to communicate. So it uses what we call an OSI reference model. So what is this OSI reference model? So there are two things that are important to us. We want to avoid duplication of equipment resources. We want to be able to interoperate or intercommunicate. So that's just because you have a Windows-based computer or a Microsoft-based computer and you have a Mac-based computer, it doesn't mean that you can't really communicate with each other. So it came up with a model, right, that we can use to kind of figure out what are the different layers and how they communicate. So to make it easier for us, so there's seven layers in that OSI reference model. Application layer, presentation layer. So I won't read those out, but an easy way to remember this is all people seem to need double pepperoni, if you like pepperoni, or all people seem to need data processing. So those are the different layers, and we'll talk about each one of these layers in detail, just to kind of see what happens at each layer. So why do we want a layered model? Again, going back to that airline, you were able to replace a part of the layer. You're able to say, here's the endpoint. Here's this, given this information, this is what I can do, right? So you can kind of modularize things. So it's easy to be able to pass data back and forth. So as you can see, I won't read what it says. You want to be able to have standardized interfaces, being able to, if we have some new technologies you want to incorporate, you're able to plug and play within there. And it's easier to learn as well. So let's look at what are the different layers, right? So So at the bottom of this is the physical layer. So what happens at this physical layer? So this layer is really, like the name suggests, physical layer. It handles mechanical and electrical communication. It translates bits into data that can be transmitted. So this layer determines how the connectors need to be. So remember we saw that Cat5 cable earlier. So how those pins need to be, what their shape needs to be, what voltages and what currents should be used, and how these need to work together. So things at this layer would be network interface cards. I know we haven't talked about those before, but NIC cards. So these allow you to connect to the internet. So we don't use those separately anymore because they're integrated into our systems. But in the old days, you actually had to buy a NIC card and plug it into your device so that you can have network capability. Hubs and repeaters. So things that allow you to repeat a signal so that it can be strengthened. So those things that don't really do anything with the data, but just amplify it, right? So that's what the physical layer deals with. So from the physical layer, so we have bits of data that are coming through the wires. What do we do with it, right? So next comes the data layer. So this layer is trying to see if there's any errors. And it also needs to know how to communicate with the physical layer. So it provides the flow, the error control, and synchronization of the physical layer. And it's able to, so remember that data is not necessarily going from physical to data link always. It could also be going, so you're sending information or receiving information. So it could be also getting data from the next layer, layer 3, which is actually network layer, which we'll talk about next. So it needs to be able to communicate with layers 3 and 1. Right, so it can take information from the network layer and send to the intended device through the physical layer on the same network. So what's important at this layer is physical addressing, how devices are addressed. Well, what is your unique address? So is this information intended for this particular device, right? So something that if you're familiar with, a MAC address is on this layer. Also, how these different devices are physically connected. The network topology that we talked about previously, is it a mesh network? Is it a star network, right? So the topology matters here. What if you didn't get all the data that you needed to get? So how do you know, right? So something that we'll talk about later is there could be a sequence number. So if you only got 1, 2, and 4, you know you're missing 3. So you alert the other layers that there was some transmission error. So you kind of control and monitor the transmission of data so the receiving device does not get overwhelmed with more traffic that it can hold. So those are some of the important things of a data link layer. So usually the OSI layer 2 is a lot more detailed than you usually think. So it's the same thing that you saw before. There's a physical layer. So here it's talking about what cabling, right? So remember 10 base 5, those things that you saw before. And then, so this is the normal one, the UTP RJ45. This is the one that we usually use these days. Fiber optic cables. So the data link layer can actually be divided into two. One is the media access control layer, and the other one is the LLC, which is the logical link control layer, because it has a lot of responsibilities in here. So they're divided into two different layers to further understand these, right? So the MAC layer, the media access control layer, manages protocol access to the physical network medium. So this layer, so it controls access and network adapter card drivers and things like that. It also enables multiple devices to uniquely identify one another. So the physical address is always unique for a device. And it also is assigned by the manufacturer when they manufacture the device. So it cannot be changed. It's hard-coded, if that's the right term to use. This layer cannot route to other networks, so it only knows about its MAC address. So it can only pass on packets in its own segment. So things that are in this layer are bridges, switches, and routers that are a little more intelligent because they know, okay, here's the data coming in, here's my physical address, is it intended for me or not, right? The LLC layer manages communications over single link. So this is the one that's in charge of doing error checking, right? So it supports different types of connection-oriented, connection-less services. So what does that talk? We'll actually talk about what those are shortly. What are connection-less and connection-oriented services? So the next layer is the network layer, as I previously mentioned. So what is this in charge of is routing of packets to different networks. And it defines a network address. This is different from the media access control address that we previously talked about. Network address is the IP address or IPv6 address that we'll talk about. Network address is, MAC address is a physical address, network address is a logical address, because your IP address may change based on what that server assigns you, but your physical address never changes. This layer defines logical network layout, so the routers can use it to determine how to forward the packets of data that they get. So routers are at this layer, the network layer, because what may need to happen is the translation of IP to physical or physical to IP based on whether you're receiving or sending information needs to happen at this point. The next layer is the transport layer. So previously I talked about connection-oriented or connection-less. Sometimes you want to know if the connection happened in a reliable format versus not so reliable. We'll talk about this further in a few minutes. But what we're talking about is whether the connection was established, the data was sent reliably or not. Something that you can, to use an analogy here, you can think about a connection-oriented service like a certified mail. So you're making sure that it will get there and the recipient says, hey, I got it, a certified mail. Versus a connection-less service would be where regular mail, you just assume it will get there. So sometimes, because if you want to make sure it gets there and you want to look for that acknowledgement, it requires a lot more overhead. So there are two types of transport mechanisms, which we'll talk about, TCP and UDP, in a minute. I'm going to break this down into two videos so it doesn't get too long, okay?